Okay, hello and welcome to Equity Education, the chemistry version, and today we're going to be looking at Group 2. Okay, so it won't be a long one today, so open up your booklets and we will get started. So, Group 2 metals, they are called the alkali earth metals, and they are in the S block of the periodic table. So, some properties. Okay, so unsurprisingly, they're all metals. They're good conductors of heat and electricity. They have generally high melting and boiling points and form compounds that are good conductors of heat and electricity when the compound is molten or in an aqueous solution. Okay, some of our chemical properties. So they follow when they react they lose electrons. So they lose two outer electrons to form a positive metal ion. They are all reducing agents, and they're reducing agents because they themselves get oxidized by losing electrons, but they reduce something else, so the other species will gain electrons, and the reactivity will increase down the group. Why? Okay, so first thing I'd like you to do is have a think about why the reactivity will increase down the group. Okay, right, so let's answer this question. So why do the reactivity increase down the group? Well, we increase the number of shells, and the number of shells increases, which means the atomic radius and shielding effect also increases down the group. Therefore, it is easier to lose an electron. Okay, and compared with group 1 metals, they have higher melting points and boiling points, and they're also harder. Again, I'd like you to have a think about this next question then. So why do they have higher melting points than group 1 metals? And I'll see if you can answer it. Okay, so if we were going to answer this, we would say that they have stronger forces of attraction between the cation and the sea of delocalized electrons. They have a greater charge on the anion, so it's charge, and a smaller radius. E.g., so my sodium cation might look like this. My Mg2 plus might look like this. So the group 2 metals have a greater charge, 2 plus compared to 1 plus, plus smaller radius. So there's a stronger force of attraction between the sea of delocalized electrons and our positive metal cation. If you'd like to know a bit more about this, I suggest you watch the video on structure and bonding. Okay, so moving on. So you've got to remember some reactions of the group 2 metals. Okay, so the reaction of water, reaction with water. So the rate of reaction increases down the group. Okay, and our generic equation is, I'll use M again to represent the metal, plus H2O forms my metal hydroxide plus gas. And if we're going to use one, we might as well use magnesium, to balance it. gas. Okay, so you'll notice that we need 2 hydroxides because there's a -1 charge here, and we know the charge on our magnesium ion is 2+, therefore it must be MgOH2. Okay, put aqueous here, but it could be solid or aqueous, as you will see about the solubility in a minute. So magnesium also reacts with steam. Okay, so it does a slightly different reaction with steam. So my state is going to be gas here, and it produces magnesium oxide as a solid plus H2 gas. This is just something that you need to remember. So the pH of the resulting solution, so we're talking about our hydroxide solution here, is between 8 and 12. So we'll write this here. So we're talking about the metal hydroxide solution. And the solubility of the group 2 metal hydroxides increases down the group. That's why it's a bit debatable about this state symbol here, but we'll stick it as aqueous for now. So the metal hydroxide solubility increases down the group, which also means if they become more soluble, we'll release more of these hydroxide ions, which means the pH will also increase. Right, over to you. So is this a redox reaction? If so, explain your answer. And I want you to do it for this equation, so the hydroxide equation up here. Okay? Okay, so we'll go through the answer. So magnesium here is 0 because it's in its natural state. Here is lost 2 electrons to form +2. So this means it has been oxidized. Can you see anything which has been reduced? Well, I would probably suggest that hydrogen is +1 here and it's 0 over here. Therefore, it has gained electrons, so it has been reduced. So we can go back down and answer our question, is this a redox reaction? If so, explain your answer. Well, yes, because Mg has gone from 0 to +2, and H has gone from +1 to 0. Okay, next reaction with oxygen. I'm sure you can work this out yourself. So, our generic equation, it's going to produce the metal oxide, and we can balance this with half O2, and we'll do an example. We won't use magnesium again, we've already used it. Let's use calcium plus half O2 gas forms my metal oxide. In this specific case, it would be calcium oxide. Okay, moving on. So uses of group 2 compounds. So magnesium oxide is a refractory metal, which means it has a very high melting point. And its use is to line the inside of a blast furnace. Okay, magnesium hydroxide, so MgOH2, is used as an antacid. And an antacid is something that you use if you've got indigestion or a buildup of acid in your stomach. And you may also see it called milk of magnesia. And it reduces the acidity in the stomach. And we can do an equation, so we might as well do an equation. So, e.g., my magnesium hydroxide, it's in a tablet form, it could be in a liquid form, but we use it as a solid with HCl. Now we should know this from our acid and base video, so a metal hydroxide plus an acid forms a salt plus water, so we know this is water. Our definition of a salt is when the H plus of an acid is replaced by a metal ion or a ammonium ion. So we replace our H plus with our magnesium to produce our salt, which is MgCl2. Let's go back and balance it, so 2HCl. Okay, calcium hydroxide. Its use is to reduce acidic or acidity in soils, and I'll give you an equation, you can fill it out this time. So we sprinkle some calcium hydroxide onto acidic soils. It's going to react with the acid in the soil. We'll say it's sulfuric acid, and I'll let you just have a go at completing this equation. Okay, be back in a second. Okay, I'm sure you've all worked it out. So we're again going to produce our salt, which is calcium sulfate, plus water, AQ. Good. We need to go back and balance it. Is it balanced? No, so we need 2H2O. Okay, moving on. So, thermal decomposition reaction. So our definition of thermal decomposition is when a compound is broken down using heat to produce two or more products. E.g., we will do a generic equation, so metal carbonate with heat produces my metal oxide plus CO2, and we will use calcium carbonate plus heat forms calcium oxide plus CO2 gas. Not particularly difficult. I'll just write in here, so thermal decomposition reactions of the metal carbonates. And again, something that you just need to remember, we don't need to do an explanation yet. So the ease at which a group 2 carbonate thermally decomposes, so the ease at which it decomposes decreases down the group. So we have to provide more heat energy to break up the carbonate as we go down the group. Okay, next thing, so testing for CO2 gas. So we would add calcium hydroxide, which is also known as lime water, and the solution will turn milky, or you may also see it described as cloudy. So what's happening? Well, we have our calcium hydroxide plus CO2, let's get rid of that. It shouldn't be solid because we've said it's lime water, so it should be aqueous, and we will produce calcium carbonate, which is solid, which is also a white PPT, which is why you see the solution turn milky. Remember, it's a liquid. It's a solution here because it's aqueous, but this is going to form a white precipitate within it, so therefore it looks cloudy or milky. And as we pointed out, this is solid here, therefore, helps if I finish this equation, plus H2O, and therefore we can say that all group 2 metals are insoluble in water. Okay, moving on. So group 2 sulfates. So again, something that you just need to remember. So the solubility of the group 2 sulfates will decrease down the group. And we can also test for sulfate ions. Remember, sulfate ions are SO42 minus, and we add a solution of barium chloride, which is aqueous, and the positive result is to produce a white BPT. E.g., if I have an unknown solution, but I'll say it's sodium sulfate, and I add barium chloride to it, I will produce barium sulfate, which is a solid. It's at the bottom of group 2, and we said the solubility decreases down the group, plus what do we have left over? NaClAq, balanced. Therefore this must be my white precipitate. So that's a test for identifying sulfate ions. Let's make that a bit more clearer. So 4. Okay. Right, and then lastly, told you it was a quick one this week. So names of some calcium compounds. So this is calcium carbonate, but you may also see it described as limestone. You don't particularly need to know it, but it's helpful to know. Calcium oxide might be referred to as quicklime. Calcium hydroxide as a solid is usually just referred to as calcium hydroxide. However, when it's aqueous, we describe it as lime water. Okay, so very quick today. Basically, it's just a lot of remembering. The only thing which involves some scientific thinking is that you've got to remember that the reactivity of the group 2 compounds or group 2 metals increases down the group because we increase the number of shells, therefore we increase the atomic radius, therefore we increase the shielding effect, therefore it's easier to lose electrons. Remember that, and remember your generic equations, and you can't really go wrong. Okay, hope that was useful, and I'll see you next time. Okay, bye bye.